Hello everyone, this is Sriman and welcome to Genius Math Minds. In this video, we will see another problem from the series Let's Solve. So this problem involves a very interesting concept called nested roots or nested square roots, because inside a square root it will have a square root. Inside that square root it will have another square root, and it goes on. So that's what this problem involves. But here we have two different nested square roots. So how do we compute this problem? So first, the problem is root of x plus root of x plus root of x, and it goes on, plus root of 1 minus x plus root of 1 minus x plus root of 1 minus, it goes on. This equals 3. So we need to find the value of x. So how do we do that is, let's take x root x plus root x plus, and it goes on. Let's take this expression as a. We'll find the value of a as a simple term, not like this radical or infinite term. So we'll find the value of a as a simpler term. So that's first what we'll do, and we'll do the same thing for this expression as well, and then finally we'll compute the value for x. So that's what we are going to do. First, how do we simplify this expression is, we can square both sides. So we get x plus root x plus, and goes on, gives a square. Now what we can do is take this x here. So root x plus equals a square minus x. So what we can do is, we know this is exactly equal to this, because we can write this as root x plus root x, because this is what this dot 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 or this infinite sequence means. So this is exactly equal to a. This is only applicable when this is an infinite root. So that's an advantage of infinite roots. So this we can write it as a equals a square minus x. Now we can form a quadratic equation with this, but the variable of the quadratic equation will be a. So a square minus a minus x equals 0. So this will be the quadratic equation. This quadratic equation is in terms of a. So we need to find the value of a. So we know the coefficient here, let's take as a, and the coefficient here is b, the coefficient here is c. We know the quadratic formula or the quadratic solution forming formula. So that is minus b plus or minus root v square minus 4ac by 2a. So this is the formula. So just substitute in this formula. So minus b. So here b is minus 1. So minus of minus 1 plus or minus root b square. B is again minus 1. So we get 1. Minus 4 times a here is 1. C here is minus 1. So we get 1 plus 4 times 1 by 2a, which is just 2. So the final value is 1 plus or minus root 5 by 2. So this is what, oh here, okay, there is a mistake here. Since this is in terms of a, all the other terms or all the other terms except a are the constant terms. So here c is not 1, c is equal to minus x. So here we put minus x. So we have minus 4 times a is 1, c is minus x. So we get 1 plus or minus root 1 plus 4x. So this is what we have here by 2. So this is the value of a. So we can write the value of a here. So this is what we had, and now the value of a is simplified as 1 plus root 1 plus 4x by 2. Here you can notice here there was plus and minus, but here I only put plus. The reason is that this expression is always in square root form. But when we take a square root of a number, it will always be in positive. So that's why here only the positive term is taken. So that's the reason for that. So we have computed the value of a, or we have simplified the value of the infinite root term. Now we'll do the same thing for the other term. So why we are doing this is we can substitute for this value as this. So we can substitute this as this value. Same way we'll do for this. So we have root 1 minus x plus root 1 minus x plus, and it goes on. Let's take this as b. So again do the same thing. So squaring on both sides we get, and it goes on up to infinity, equals b square. So we have squared the term. Now take all the terms that are not under square root to the other side. So root 1 minus x plus root 1 minus x, and it goes on. So take this 1 and minus x to the other side. So we get b square plus x minus 1. Here these two are considered as constants because this is the quadratic variable term, that is b. So this we can again see, this is clearly b. So b is equal to b square plus x minus 1. So form the quadratic equation b square minus b plus x minus 1. This is the constant term. So here a equals 1, b equals minus 1, c equals x minus 1. Doing the same thing for b. b equals minus b. So minus of minus 1 minus b is minus 1. So minus of minus 1 plus or minus root b square minus 1 the whole square is 1. b square minus 4 times of a. a is just 1 and c is x minus 1. So this is what we have here by 2 times of a. So we can simplify this as 1 plus or minus root 1 minus 4 times of x minus 1 by 2. So this is the final value we have for b. Again we need to write only the positive term because this is also under square root. So we have computed the value of b, a and b. Why? Because we are simplifying the nested or the infinite square root term. So instead of b we can write 1 plus root 1 minus 4 times of x minus 1 by 2. So this is what we have here. So this value is a and we have simplified this as this expression. This is b and we have simplified this as this expression. So we can write a plus b equals 3. So this is the expression we have here. So now the value of a is 1 plus root 1 plus 4x by 2 plus b 1 plus root 1 minus 4 of x minus 1 by 2 equals 3. So this is what we have now. If from this expression this is easier to find the value of x because the result is the value of x. So that's what we need to compute. So here from this expression the denominators are common for both these terms. So 1 plus root 1 plus 4x plus 1 plus root 1 minus 4 of x minus 1 whole thing divided by 2 equals 3. Now just usual algebra to simplify. So 1 plus 1 is 2. These two terms are not common or not the same. So we can write them as root 1 plus 4x plus root 1 minus 4 of x minus 1 equals, we can take this 2 to the other side and multiply with this 3. So equals 6. So this is what we have now. How do we compute from this is, we need to get rid of the square terms. So that's what we are going to do. So we can first take this 2 to the other side. So 1 plus 4x plus root 1 minus 4 of x minus 1 equals 4. So 6 minus 2 gives 4. So we need to now get rid of the square roots. So that's what we are going to do. So how do we do that is, take one of the square roots to the other side. So I will keep this square root here and keep this square root the other side. So root 1 plus 4x equals 4 minus root 1 minus 4 of x minus 1. So this is what we have. Now we are squaring on both sides. So we will get 1 plus 4x. So the square root and the square get cancelled. Equals, we need to apply the a plus b the whole square formula here. So this is a and this is b. So we have minus a. So we are using a minus b the whole square. So a square, which is 4 square, which is 16, minus 2 times of a, b is this one. So root 1 minus 4 of x minus 1 plus b square, which is this term, 1 minus 4 of x minus 1. So this is what we have here. So this square root and the square gets cancelled and we have this term. So now we have only one square root term. So just do some algebra first. So we have 1 plus 4x equals 16 minus 8 root 1 minus 4 of x minus 1 plus 1 minus, distribute this minus 4. So minus 4x plus 4. So this is the term we have left. So now it's just simple to get rid of the only square root term we have now. So first simplify this expression. We have x term here and x term here. So we'll have 8x. So we got rid of these two terms. So minus 4x comes here. It's 8x. We have 1 here. We have 16, 1 and 4. So first add these. 16 plus 1 is 17. 17 plus 4 is 21. So plus 1 equals 21 minus 8 root 1 minus 4 of x minus 1. So this is what we have. We can take this here. So 8x minus 20 equals minus 8 root 1 minus 4 of x minus 1. So this is what we have here. Since we are negative, more number of negative signs, we can multiply the whole expression with negative. So we will get minus 8x plus 20 equals 8 root 1 minus 4 of x minus 1. So this is what we have left. So now compute or squaring on both sides again. Okay, if you see this expression, we can divide the whole expression by 4 to reduce the value. So dividing by 4, we get minus 2x plus 5 equals 4 root 1 minus 4 of x minus 1. So this is the expression we have left. So now if we square on both sides, the problem is almost over. So we need to square on both sides to get rid of this square root. Oh, I have made a mistake here. 8 divided by 4 gives 2. So that's what the term here is. So squaring on both sides. So minus 2x plus 5 the whole square equals this square, 2 square is 4 and the inside term is 1 minus 4 of x minus 1. So this is what we have here. Now we got rid of all the square root terms. So now just basic computation. So square this, we have 4x square plus, or we have 4x square minus 2 times of AB. So we have 2 times 5 is 10, 20. So 20x plus 25 equals 4. Distribute this 4. Okay, we'll first distribute this term. So 1 minus 4x plus 4. So we have 4x square minus 20x plus 25 equals 4 minus 16x plus 16. So now add the like terms. So we have 4x square. X terms are minus 4x. So minus 20x plus 16x gives minus 4x. Now 25. So here we have 20. 4 and 16 gives 20. So 25 minus 20 is 5. So this is the quadratic equation we want, because this is just a quadratic equation and we can find the value of x from this easily. So now we will compute the value of x from this quadratic equation. So again we use the quadratic formula, x equals minus b. So minus of minus 4, because b is minus 4, plus or minus root b square. So b square is this minus 4 the whole square, which is 16. B square minus 4 times of a is 4, times c is 5, whole thing divided by 2 times a, which is 2 times 4, which is 8. So if we solve this, the answer is over, because there are no variables here, only numbers. So minus of minus 4 is 4, plus or minus root 16, okay, we'll put 16. 4 times 4 is 16, 16 times 5 is 80. So minus 80 by 8. So just get rid of the square root there. So we have x equals 4 plus or minus root 16 minus 80 is minus 64 by 8. So this is what we have. So now if you see this, the determinant is minus 64, which means it is less than 0. So we only have imaginary solutions for this problem, or for the value of x. So if we do that, 4 plus or minus, the square root of 64 is 8, and the square root of minus 1 is I. So we have 8i by 8. Now distribute this 8 to 4 and 8i, we get 1 by 2 plus or minus I. So this is the final answer for this problem. So the value of x we have computed is 1 by 2 plus or minus I. So there are no real solutions to this problem. So the only solution for x is 1 by 2 plus or minus x. So the value of x is, we need to write like this, 1 by 2 plus I and 1 by 2 minus I. So these are the two solutions for this problem. So we have computed the value of x, which there are two infinite square roots. So we are computing the value of this expression, we are computing the value of this expression, then we are adding them and we find a quadratic equation, then we solve that and we get the value of x. So this is how you compute, or how you reduce, or how you deal with infinite square root problems. So that's it about this problem. Thank you.